Okay, so now that we kind of determined how to solve systems of equations by substitution, I'm just going to teach you quickly how to solve it by something called elimination. So in the last video, we found that the solution to this was 6 and 18, and now we can use something called elimination to kind of figure out the same thing. And in this video, I'll also confirm it algebraically, which is what the question's asking. So in substitution by elimination, we're always looking to eliminate. That's where it gets the word. We're looking to eliminate one variable. So you can choose, well, do I want to eliminate the x or the y? I'm going to eliminate the y in this one just because it's a little easier, and I'll show you why in a sec. So if we eliminate one variable, that means that we're just left with the other and we can solve, right? So I'll show you right now, if we take the top equation, right, and for every term, right, the x, the y, and the 24, if for every term we added what was directly below it in the equation below here, we're gonna kind of eliminate the y variable. So we'll just be left with x's and constants, which is good. So see how in this first term here we have an x, and right below it we have a 2x. So if we add these two equations together, we just add the like terms together. So we get x plus 2x. Okay, so I'll write that, x plus 2x. Okay, so that part's good. How about y minus y? So y, we got plus y minus y. Okay, and that's going to equal the other side, 24 plus whatever's below it. So 24 minus 6, right? Because we're adding a negative, we're subtracting, so that part's good. We're all done. Now see how when we add x and 2x, we'll just kind of combine this together to make 3x. But we have y minus y, right? And anytime we have a number or a variable and we subtract that same number or variable, it just disappears. So we don't have anything after that. 3x equals 24 minus 6, right, which is 18. We can just divide by 3, right? And we get x equals 6. And like we did in the last question, we can kind of plug 6 into one of the equations. You always choose the easier one. So x plus y equals 24. 6 plus y equals 24. Subtract 6 on both sides. So y equals 18, and you'll get the same solution. So elimination can kind of be helpful if substitution would take a little longer, right? Or if you just wanted to have like a quicker method. It's always nice to know different ways to do things, kind of to get to the same point. And below here, I just kind of copy and pasted graphs from Desmos here, and just to kind of confirm that the solution is correct. So like I said before, I had no idea what these graphs would look like. All I knew was that if you kind of drew a line straight down from the x, this would be 6, and straight across from the y, this would be 18, right? So this is kind of where they intersected. It doesn't matter a whole lot how these graphs look, right? Because we're just solving it algebraically, but we just know that this is where they intersect, okay? So if we wanted to confirm this algebraically, we would take our x and y components and just make sure that they work, right? We'd plug both of these in and just make sure that they're valid for both equations. So we have to do it for all the equations in the system. Okay, so x plus y equals 24. Let's just plug in 6 for x plus 18 for y equals 24. Okay, we know 6 plus 18 is 24. So 24 equals 24. This equation is good. It seems as though our solution's working so far, but in math, we always have to check that we're right for kind of every step of the way. So if we plug in x for this part, 2x is 2 times 6 minus whatever y is, which is 18, equals 6. Or sorry, equals negative 6. My bad. So 12 minus 18 equals negative 6. And indeed, negative 6 equals negative 6. So it doesn't matter what this number exactly is. All that matters is that it's the same on both sides. So negative 6, negative 6. is the same, 24 and 24 is the same. So if your numbers work for every equation, then you've effectively solved the system of equations. So hopefully that's kind of an introduction into systems of equations, what they are, how we can solve them, and just remember that when it wants you to solve a system of equations, basically you're finding where the graphs intersect if there's only two equations. Okay. Another point I really want to drive home is there's not always going to be only two equations. So there could be something like, let's say, x plus 2y minus 3, and then they could introduce, or sorry, instead of x here, I'll write plus 2y minus 3, they could introduce a new variable z here. Then they could say 3z minus x equals y. And they could say y plus 2 equals x plus z. Right? So I'm not going to solve this in this video, but we have one equation here. Then we have our second equation and our third equation. We can solve this. There is a way to solve it because there's three variables in each equation, and there's kind of three equations, three relations that we can use to isolate for one. So how you'd go about doing this is I would probably use the second equation here because it's already isolated for y, and I would kind of plug 3z minus x wherever I see y into this first equation. Right, so this would be x plus 2 times 3z minus x, and minus 3 equals z, and you would know that whatever's on this left side here equals z, and you would take all of this and you would plug it into where you see z in this third equation. So substitution is probably the way to go when there's three or more equations, but when there's two, you can also use elimination, just kind of adding some tools to your toolkit as you kind of traverse forward into your mathematical journey. So I hope this video was helpful, and I'll see you in the next one.